Hello everyone. Okay, so today we continue last time the quantum. Okay, last time we learned about a few formula. It is E equals to HF and a photon. E is photon. Photon is directly proportional to the frequency of light. Okay, so last time we said the rainbow color is Roy give birth. Okay, so red has actually the wave, EM wave started from radio wave, then ends up with gamma ray. So always remember RR is really long apa wavelength. So since V equals to F lambda, F equals to V over lambda, wavelength increases means frequency decreases. So R has longest wavelength in visible light, but frequency is the lowest. Okay. Then, because velocity is the light speed, so we substitute C. What is C? C is the light speed. C is the light speed, which you can find in your calculator constant too. Okay, so lambda equals to h over p. This one, why there's lambda? Because of the wave particles duality. Okay, so we say that since it got particles, this formula is for wave. Since inside got particles, so we say particles got mass and then it's traveling within a speed. So we say P equals to mv. Means momentum P equals to mv. Okay. So where can you find this formula? It is in Form 4, Chapter 2. Momentum P equals to mv. So actually what is momentum? Simplify it, we can say it is a moving body or moving object. When we say object or body means inside got mass. Moving means got velocity. So we say momentum is the product of mass and velocity. Okay? So this is for wave particles duality. This is for wave, this is for particles. Okay, so this is how we get the formula lah. And then don't worry, here we can get the formula. Okay, then because this one can substitute become this one. Okay, so we can see HF or HC over lambda. Then what is this? This is called power equals NHF. That might we see later. Now let's solve the problem first. Okay, so 1 megawatt laser generate a green light of wavelength this. Calculate how many photons are generated from the laser per second. Okay, so info first. So it's 1.0 MW. Okay, Uh, Actually, what is it? It is P. P equals to 1.0 times 10 powers of negative 3 watt. Generates the green light of wavelength. Wavelength equals to 514 nanometer. So be careful, we must change nano to 540 times 10 powers of negative 9 meter. Okay, you can get it from your calculator, which is this part. Okay. This calculator don't have. Normally 380 ms don't have. Only this one. Only 570 ms got. See, nano is above 3. So shift 3, then you will get nano. Okay, nano is times 10 powers of negative 9. Calculate how many photons. Okay, so you might forgot already. Photon actually means E. E equals to HF. The E is called photon. Okay, then what is photon? Photon actually is discrete form. We can summarize it as a packet of energy. You can see this is a packet of energy. Here got quite a number of energy, but they are discrete in a packet. So we say E actually is photon. Sorry, not photon. Quantum energy. So correct. Photon. So photon means we want to find photon. So what is the formula we can use? See, we got power, we got lambda, and then they ask for how many. How many actually means n. This n refers to numbers of photon. How many photon? How much? How many? Alright, so normally we can use this lah. P equals to NHF. Where is it? Here. Uh, okay. Here. If n is the number of photon emitted per second, state the power. Power equals the energy over time. So power equals to energy over time. Okay, and then power equals to NHF in HF. Power equals to NHF. Okay. So we can substitute first. Since this one looks more complete, so we can say power is 1 times 10 powers of negative 3. Watt equals to N. H is the constant that we give, or you can find from the formula is 6.63 times 10 powers of negative 34. 6.63 times 10 powers of negative 34. And the frequency. Don't have frequency. How? It's okay. We can find frequency ourselves by using this formula. Actually, this formula comes from chapter 5/4, which is V equals to F lambda is a wave, but the wave speed for EM wave is C, light speed. So we can say F equals to C over lambda. So now if we want to find F, since lambda is given, we can calculate also. F equals to C over lambda comes from where? C equals to F lambda. Okay, so I always encourage you all to remember the original formula. Then we derive it ourselves. So we can memorize less formula. Okay, so or you can just find it here. Okay, so now C is 3 times 10 powers of -8 divided by 540 times 10 powers of -9. So you will get the F, then you substitute back here. Hi, Chunpai. Hi, you're from 4 or from 5, Chunpai? From 5, right? Oh, how? Okay lah, if you're free, you join lah. Okay, I think something went wrong. My message doesn't sampai. Can you help me to forward my message to your class or some other class? Thank you. So, I think my fault, but never mind, we continue. Okay, so now power equals to NHF. So we substitute this F to here. And then we will get N, how many photons. They don't want E. They want how many photons. So actually it's N equals to equal sign. So press calculator and check answer. Okay, so now it's the time we test our application for formula. Okay, so I erase all of this. So far, the formula we can use is 1 to 6 so far. Okay, so now this is tugasan 1. Okay, an electron moving at high speed has dipole wavelength of 10 powers of -10 meter. Determine the velocity of electron given that the mass of electron is this. So what do we want? We want the velocity of electron. Okay, then if we just refer to the velocity of electron, we can see here don't have velocity. This is light speed. Yes, it's here, number 4. Only 4 got velocity. So we check one more time about info. Okay, so info is wavelength 10 powers of negative 10 meter. Velocity don't know. Mass of the electron 9.1 times 10 powers of negative 31 kg. Then A, yes, correct. Fulfill number 4. So we copy the formula. Please copy. Then only we substitute. So 10 powers of negative 10 equals to H is over here is Planck constant, Planck, whatever. 6.63 times 10 powers of 34 divided by the mass 9.1 times 10 powers of negative 31 times V. Then algebraic formula, solve it, calculator, then you will get can check answer yourself. Alright, then next 8. Calculate the energy and wavelength of light photon with frequency of this. So now what do they want? Energy and wavelength with a light photon means a light with frequency of 4.72 times 10 powers of 14 hertz. Okay, so first of all, this one easy lah. When you see F lambda, we know lah. It's actually C equals to F lambda. So C equals to F lambda. Lambda equals to C over F. C is what? Light speed. You can get it from nuclear physics. C equals to 3 times 10 powers of 8 divided by frequency 4.72 times 10 powers of 14. And you get, press calculator, you will get the answer. And how about E? Energy actually means photon here, photon. So you can use HF or you can use see number 1 and number 5. You can use HF or HC over lambda or E equals to HF. So substitute lah. H is over here 6.63. 6.63 times 10 powers of negative 34. Then F is here. Substitute and you will get answer in joules. So far, okay? So actually, yes.
发现这那些东西是我的意思，所以
啊，什么意思？
老师，请问黑是
啊，我听不到，听不到，
是
听不到。
H
啊，H 什么？啊，什么？听不到啊？Hello，一松，Hello，我关掉 camera 一下，有比较好吗？听到我讲话吗？一松，H 的意思哦，H 的意思叫做 Planck constant，普朗克 Planck constant，普朗克的一个 constant。但是上星期我们讲是加热普朗克 Max Planck， 他跟爱因斯坦他们讨论了过后得出的，也不是跟他们讨论了，就很多人做了很多 experiment 过后，他发现 energy quantum energy directly proportional to F。quantum energy 是directly proportional to frequency of light. And then you all know lah, if you need to change directly proportional to an equal sign, there must be a constant as a ratio. So actually means whatever E divided by its F will equals to a constant number, a ratio. You learned this since when? Since from 2 circle. Circumference equals to 2 pi r. Actually, its circumference equals to pi d. 2r actually is 1d. So we say what? We say C is directly proportional to the diameter. Circumference is directly proportional to the diameter. So if we change to an equal sign, it must be a constant. So we will get a pi. Means whatever, no matter how big or how small is the circle, you use the circumference divided by diameter, you will get the pi as a constant number. So what is pi? All of you know lah, about 22/7 or 3.14153. Okay, so actually H, a constant, actually is a ratio. E divided by F equals to this ratio. C, circumference divided by the diameter, equals to the pi. It is a constant number. It's a ratio. Okay, so the H comes from the experiment. So Planck, he did many experiments and he find out that as long as you use E divided by F, you will get a constant, a Planck constant. They name it as a Planck constant. Okay, so let's see one video. Okay, this is Lonnie. It's Lonnie.
We're in the demo lab with Lonnie, where he set up a photoelectric effect experiment. He has white light impingent on a metal, and the energy of the photoelectrons emitted are shown on the meter at right. If he puts a red filter in the path, now only red photons can strike the metal, and you can see they do not have sufficient.
So he said, we name the light as photon. If this is red light, we say it's red photon. Means what? Means we say if this is red filter, means only the red light can pass through. So red light actually got what? Got energy. So red energy, red photon and red quantum energy, red photon. We don't say red light energy. We say it as red photon because photon is a packet of energy. Okay, so we say actually red light contains red light energy. But we don't say it's red light energy. We say it's red photon. Okay, red photon. Okay, so now understand the meaning of red photon. The photon, it's energy. Okay, so all of this actually is the practice of formula 1 to 6. So you can copy above here before you do, or you just put your formula list beside. Okay, put your formulas beside. Okay, so a few things you need to be careful because you might not sensitive to nm. What is nm? It's nanometer. So it's 560 times 10 powers of negative 9 meter. Please change to SI unit m on me. Now, nanometer, be careful. This one, wavelength 1.0 pm. Doesn't mean 1 pm. No. PM, P means picometer. So where is pico? Now here, okay, shift 2. 1 shift 2 pico, then equal sign. So pico actually is 1 times 10 powers of negative 12 meter. Okay, pico is your 1 shift 2. Nano is 1 shift 3. Okay, so the rest all like that lah. Number of photon is n. So this one is, if they give what means the formula is this lah. Power equals to numbers of photon times HF. This one I already showed in page 200. Sorry, I recorded. Okay. Now this one, M means milli. Milli means times 10 powers of negative 3. Okay, so it is here. Shift 5 is milli. Okay, or I make it larger. Now, milli is shift 5. Okay, so now let's see actually what is a photoelectric effect. Okay, so same thing as every time when I start, I will introduce what is the name. By the way, any question about up here? No. Okay lah, before we proceed, tell you a funny story about Einstein and De Broglie. Yeah, Einstein is here from 1879 to 1955. De Broglie is 1892 to 1987. Okay, they have argument about De Broglie wave particles duality. Okay, apa itu wave particles duality? And then and then comes up another scientist. Actually, this quantum physics is very rough introduction. Okay, it's very rough introduction. So it comes with the cat. Yeah, they like cats like me. Last time they also breed cat inside the lab so that can catch what can control the rats. See, meow. Okay, so this is the famous experiment, just imaginary experiment. Now, Erwin Schrödinger. Yeah. I like this cat, Schrödinger cat. Okay, it's both different and indifferent. This is cat's eyes for total internal reflection. Cat's eyes. Okay, so this is just imaginary experiment. No, 薛定谔的猫，没错。来，我们来记它，叫做 Schrödinger，S-C-H-R， Schrödinger，薛定谔的猫。Okay, so when the Bride said this, wave particles duality, many students, many people cannot understand. So Schrödinger's Schrödinger give out an imaginary experiment that is inside a box. There is a setting. This is a radioactive substance. And then if this radioactive substance suddenly got extra radiation, okay, then it will switch on. It will switch on the setting, break a chemical, break poisonous chemical, and this chemical will kill the cat, so the cat die. Okay, if this one don't have extra radiation, then this cat alive, will maintains alive. Then, how do you know it's alive or die? Before you, this is a box, right? So before you open the box, this cat can be dead, can be alive. It has two possibilities. We call it as duality. We are not sure. It's the probability, probability. Cannot sure. Okay. Means when you open, it's alive or it's die. Don't know. Like the dice of the god. You never know how it will be. So he said this is so the cat may be alive, maybe die. So it's like the particles have wave particles duality. How do you know when it is wave? Or how do you know when it is particles? When you open the box, then you know. Open the box means what? If you do experiment for wave, you will find out, oh, it's wave. But if you do experiment to discover it is a particles, yes, it is a particles. Okay, so before you test it, before you open the box means you test it out. You will never know until you test it. You test with wave, yeah, it's wave. If you test with particles experiment, yes, it's particles. Then how is the probability? Is the God dice, God's dice. 上帝抛的骰子，我们不知道它到底有几点。这个就是很出名的Schrödinger cat， 薛定谔的猫。那到底是生还是死？你要看到才知道。OK， Schrödinger cat，Schrödinger's cat。这个就是它的 formula。你可能会问这是什么啊？不要紧，不要紧，我们没有学，考试没有考 ，OK， 看它可爱就好了。Okay, don't worry, Schrödinger got dot here. I think he's a Germanese. Not so sure. Okay, but don't worry, we don't test this. Okay, Schrödinger's cat. Then this experiment not accepted by Albert Einstein. Albert Einstein said, "Mana boleh. We physicists must have a absolute answer. Why you say probability? But until Albert Einstein died, he still cannot prove the best solution. Cannot beat this probability lah. Okay, so we say when two conditions may possible exist. So we could call it as Schrödinger's cat. Like you lah. You don't know the physics mark yet, right?
老师，我是觉得是耍丁个。
So you might fail or you will pass. Yeah, so now your result is Schrödinger's cat. Or some people say I sure A plus. Maybe you are A. How do you know? Before you test it, it's Schrödinger cat. 好，医生。好，医生。是吗？老师，我每个科目都是学定2的嘛，哈哈哈哈。Okay. Isong say every subject is every subject is Schrödinger cat. Okay, so that's Schrödinger cat lah. That's wave particles duality lah. So now let's see its photoelectric effect. Oh, by the way, this is the video I downloaded from YouTube. Should I embed the original video link? Anyone know or not? If not, I might be 盗版, is it? Anyone knows? Should I embed the original link? No one knows? Yeah, later I put the link in the description. Okay, so now what is a photoelectric effect? Now this is photoelectric effect. Let me find a photo. Photoelectric effect. Oh, this one, very good. It's very good. The set photoelectric. Okay, photoelectric effect means photo is light. Electric means electron is moving. Electron is moving means what? Electron is flowing means I equals to charge over time. Charge flows per time. So electron is flowing means it will produce current. So light can produce current. Before this, we learned electromagnet, right? Faraday. Before this, we learned Faraday law. Faraday law say what? Say this is electron. When the magnetic flux cut on conductor, current I is induced. Okay, but for quantum world, light also can create current. How? Okay, so it's like this. This is a metal plate. Okay, this is a metal plate. Baru sih. Ya, Alright, my cousin come back home. Okay, so now the light rays is photon. So we can say this is a photon. Okay, this is yellow light. So we can say it's yellow photon. Okay, so we know that actually electron come from the metal. So the metal got a lot of free electrons. Okay, so when the yellow photon strike on the metal surface, okay, the electron will gain enough energy and then go out. So go out means they escape out with kinetic energy. Okay, so photon is energy. Then they gain enough energy to escape out. Also got energy, kinetic energy. Then what kind of energy is gained before? Because all of them has attraction force. So you all know lah. So the force that used to resist the attraction force, we call it as what? Sorry, suddenly blue. Threshold and threshold frequency. Not threshold frequency. It's called work. Wait a minute. On. Hi. This is not Schrodinger's cat. This is my cat. Okay. Um, sorry, 我在录，不好意思。Okay, so okay, so I'm sorry, I suddenly cannot find out what's the energy. What's the energy? Wait. No. I think this is it. Work function. Yeah. Yes. Finally, I get it. It's work function. It's work function, finally. So, work function. Actually, what is work? Work and means energy used. Energy used. Okay, so all of these are energy. Photon are energy. Work function used to resist, break the bond is work function. Energy used to break the bond, work function. And when the electron get up, it will move in a speed. So it is kinetic energy. So we can get a conclusion from here. Photon is E equals to work function is W naught, means minimum energy used to break bond. There would be absorbed, and then plus KE max. Plus KE max means it will go up with maximum kinetic energy. Okay, so let's say total energy here is 10 joules. Then work function will be absorbed by the metal is 4 joules. Means what is the escape energy, kinetic energy here? Sorry, escape velocity is depends on the kinetic energy, means 6 joules. So can you understand that? Photoelectric effect means you got 10 joules of photon absorbed by 4 joules of energy, the energy absorbed, we call it as work function, plus 6 joules of kinetic energy, maximum kinetic energy. Okay, so now this is the formula. So where is the formula in the list? It's over here. It's here. But they didn't write as what I say. It's E equals to W naught plus KE max. So what is this E? E is photon energy. Photon means a packet of energy equals to W naught is HF naught, means work function is HF naught, minimum energy need to be absorbed to break bond, plus kinetic energy half mv square max. We have learned this in Form 3. Okay, so this is the last part called photoelectric effect. Means when the light strikes on the metal surface, electron will be released out. Electron will be escaped out, means it's flowing, means light generate electric current. Let's see a video. Let's see a video. Okay, this is the video come from this professor.
One of the big ideas in physics is that light can behave as waves or particles, and this demonstration of the photoelectric effect is a really great way of introducing that idea. What I've got here is a zinc plate.
This is a zinc plate. Okay, they put it on electroscope.
And if you want the demonstration to work, it's absolutely essential to give it a good scrub on both sides with a bit of iron wool.
Okay, so we make it clean.
And that just removes the surface oxide layer. I then place the plate on top of this gold leaf electroscope.
Gold leaf electroscope means when there is, now this is brass and this is gold leaf. Okay, so now it's not neutral because plus minus minus plus plus minus minus plus is neutral, so it doesn't move. But according to photoelectric effect, when electron is released down, so just now it's like positive, negative, negative, positive, positive, negative, negative, positive. So when electron is released by the light, so electron is negative, so there are extra negative charge here. So they would diverge out because same charge repel. Okay, thanks to Professor, I will embed your video link. Okay, so now see what will happen. Will the light release makes the electron goes up?
I've also got an ordinary desk lamp and a UV lamp. Now, in order for the demonstration to work, this plate has to be negatively charged, and I can do that using the method of charging by induction.
Okay, so now this is charged.
Now let me show you that again. I've got a perspex rod here, which I can make positively charged by rubbing with this bit of cloth. I bring the rod close to the plate, touch the plate with my finger, remove my finger, then remove the rod. Now watch what happens when I shine visible light onto the plate. Absolutely nothing.
Nothing happened. Why? Later.
That's actually a really important part of the demonstration. Your students need to notice that with visible light, nothing happens. But watch what happens when I shine ultraviolet light.
This is UV light. Okay, so let's recall Roy give birth. Roy gave birth. Okay, so Roy give birth means red light here, violet, purple is here. UV means ultraviolet. UV, ultraviolet. Ultra means more than. What is more than violet? Frequency of UV more than. So this one has higher frequency. So as we know, photon actually is directly proportional to the frequency. So as frequency increases, the photon increases too. Photon means the packet of quantum energy. Okay, let's see. When UV shines on it, what will happen?
You can see that the gold leaf immediately starts to fall.
The gold leaf starts to fall.
And that must mean that the UV light is somehow discharging the electroscope. We know that we started with negative charge on the plate, so the UV light must somehow be releasing the electrons. And the important thing to notice is that it's the frequency of the light that makes a difference. Remember, with a visible light, it doesn't matter how bright it is or how long it shines for, it doesn't release any electrons. Now, this phenomenon cannot be explained using a wave model of light, but we can understand it if we adopt the idea that radiation arrives at the plate as packets of energy, which we
UV lamp.
can call quanta or photons. A single photon of UV light can release a single electron from the plate. However, a single photon of visible light has less energy and so cannot release an electron. Now, this is a relatively
Okay, so normal visible light cannot release the electron down. So actually now this is positively charged. Just now what he do is he charge it become positive. Okay, then only when
simple demonstration to do. It's that work that he was awarded the 1920.
okay, so just now it's like this, charged positively. Then when UV light shines on the zinc plate will release electron and neutralize the charge, so the gold leaf become closer. Okay, so the diagram is like this. So when the light shines on the metal plate, it will give out the electron, right? So let's see another experiment about Lonnie. Hi Lonnie, thanks for his
We're in the demo
question.
lab with Lonnie, where he set up a photoelectric effect experiment. He has white light.
Okay, now, this experiment he set up. I make it yellow. Okay, he set up. This is called photocell. Photocell. Cell means it's like a battery. It will produce current, produce electric current. Photocell means what? We use light to create the current. Okay, so the connection here is like here is the source of light, and here we'll put a filter. If the filter is red, so it will give it a red light. So we say it got red photon. If it is a yellow light, then we say it will give out the yellow photon. All right, then here inside has the metal plate. And when you shine the light on it, it will produce out current to flow into the milliammeter. And the milliammeter, the image is posed on the screen. Okay, this is multimeter, sorry. This is multimeter to show there is current flows. Okay, so now this is using white light. White light means what? Got Roy give birth. White light got Roy give birth. 红橙黄绿蓝靛紫. So violet ray will have the highest frequency, means it will have highest photon, means highest energy. Where red light has the lowest frequency, means the lowest photon. So see what will happen if red photon is shine on the metal. So this is white light, so maximum lah.
Impingent on a metal, and the energy of the photoelectrons emitted are shown on the meter at right. If he puts a red filter in the path, now only red photons can strike the metal, and you can see they do not have sufficient energy to eject photoelectrons.
Okay, so you can see here, what we can see is red equals to 0. Can say 0 ampere, 0 volt, or what. Okay, means red photon actually do not have sufficient energy to mix the electron escape out. So just now I say, let's say photon. Let's say photon means photon, the packet of energy equals to work function plus Ke max. Let's say photon for yellow is 10. Then work function at least 4. So the energy will be 6. Kinetic energy will be 6 joule. But for red, actually it might have 3 joules of photon energy. So because 3 joules is not enough to against the work function, that's why we don't have electron escape out. So actually this is 0 lah. Yeah, of course it's not, you may say it's -1, means nothing, no energy, not enough energy for electron to escape out. Okay, so red, remember red, always not enough energy for photon to escape out, not enough energy. So let's see what will happen. Let's see what will happen next.
Photoelectrons. If we go to higher energy photons, say go to yellow light, that's shorter wavelength and higher energy photons, they may be able to eject photoelectrons. And indeed, photoelectrons.
Yes. Now yellow is enough. Frequency is high enough to eject the photoelectron. Means you can see lah, here got some reading lah. Okay, then red, no, red is 0. Okay, and let's see if we increase the frequency, means we change to the different light.
Electrons are emitted, but with a relatively small energy. If we go to higher still photon energy, green wavelengths, that's shorter wavelength still, higher photon energies, we can see photoelectrons.
So now you can see red will have higher energy, higher photoelectron emitted out.
Emitted at a higher energy. Now we can still go to higher energy photons. Blue photons, photons in the blue region, are the highest energy visible photons, and Lonnie has a blue filter that will pass only blue photons. Putting the blue filter in the path,
now you can see blue is here, around 6. So so that's why the sequence you must remember so that you can determine the frequency, increase or decrease. Okay? We always remember in this, R means really long, long wavelength lambda. So long wavelength means short frequency.
shows photoelectrons emitted at the highest energy. So here's an example of the photoelectric effect.
Thanks to Lonnie. Now can you understand photoelectric effect? Any question? 有问题要问吗？白色光最强，因为它里面有 violet。Okay, the white ray has the strongest current because strongest photoelectric. The current flows, the electron flows. We call it as current. So we say the current produced by the light called photocurrent. Photoelectric. Okay. Then the electron emitted out from the metal by the light, we call it we call it as photoelectron. When photoelectron starts to flow, then we call it as photoelectric, means the current. Okay, so now let's do some exercise about photoelectric. Okay, so we explain this next time. Okay, so what is the threshold? Sorry, what is the work function? Work function means the minimum energy absorbed. Okay, so then what is the threshold frequency? Threshold frequency means minimum frequency to achieve work function. Okay, minimum energy to achieve work function. That's why work function means energy used to break the bone equals to HF naught. Okay, so now let's do some exercise. And normally the threshold frequency is on the x-axis. Okay, now for example, contoh 1. In an experiment on photoelectric effect, the graph of maximum kinetic energy Kmax against the frequency of emitted means release photoelectron from the metal surface. This one emits photoelectron, electron emission emits photoelectron from a metal surface is found to be straight line as shown in the diagram. Calculate what is the threshold frequency. Threshold frequency is F naught, means minimum frequency that can emit the photoelectron. So obviously must be higher than the red light frequency lah. So it's around here 8. So what can we do? We can use what can we do? Y equals to mx plus c. Okay, suddenly I blank. Threshold frequency. Threshold frequency. HF equals to W plus F. So E equals to W naught plus KE max. Okay, so what is E? Okay, so this is E equals to W naught equals to HF naught plus KE max. KE max would be, oh here, KE max would be 3. KE max would be 3. 3 what? 3, don't forget, look at the unit of x-axis. Actually it's 3 times 10 powers of negative 19 joules of energy. Then what is the EF? E here, this is HF. F is this. So we substitute lah. This is the HF. So I will substitute. H is 6.63 times 10 powers of negative 34. 6.63 times 10 powers of negative 34 times 8. F is here. 8 what? 8 times 10 powers of 14 equals to H again. 6.63 times 10 powers of negative 34 and F naught means here lah, A lah, or you can substitute A plus 3 times 10 powers of negative 19. Okay, we look at maximum. So this one maximum means here HF photon. Then we solve it lah. Can you solve it? Solve it means we use this times then minus this divided by this one. In hertz. Then what is work function? Work function equals to HF naught. So same thing, 6.63 Planck constant times 10 powers of negative 34 times F naught that we gain from here. Substitute. Okay, so now this two is the same lah. Okay, the production of photoelectric current in photocell circuit. So this is the photocell. You give light, and then this cathode means negative. It will produce out electron towards here, and then it will light up. Okay, so light will give out cathode. The cathode will be emitted out and go in, and is attracted to the positive anode, then goes through here. The current will go through inside. Okay, so now A, they ask, when red light is incident on the metal surface, means shine on the metal surface coated with cesium or whatever, like it's a metal surface, no current is detected by the microammeter, but when the blue light is incident on it, current is detected. Explain. Okay, they gave this. The threshold frequency of cesium is this. Means what? Work function of cesium. Cesium is a kind of radioactive metal. Equals to H times threshold frequency. Means minimum energy need to be absorbed and break bond of electron equals to H times F naught. Okay, so this F naught would be 5.16 times 10 powers of 14 hertz. Okay, F naught. Then look at this. Light, red light has this frequency, blue light has this frequency. Okay, anyone can tell me why red light shines on cesium, no current is detected, means no photoelectric. But blue light is incident on it, can detect the photoelectric. Do you want to see Lonnie again? Hi, Lonnie.
Where he set up a photoelectric effect experiment. He has white light impingent on a metal, and the energy of the photoelectrons emitted are shown on the meter at right. If he puts a red filter in the path, now only red photons can strike the metal, and you can see they do not have sufficient energy to...
Because don't have sufficient energy. Okay, so red photon, red light means red photon does not have sufficient energy to emit electron. Does not have sufficient energy. What does it mean? Because red photon has frequency less than threshold frequency. Threshold frequency means minimum you need this frequency. Threshold frequency means minimum energy needed, minimum frequency needed. So 4.62 is less than 5.16 lah. Less than means so the work function is not enough. So does not have sufficient energy to emit electron. Then why blue? So we say Blue ray, blue light means blue photon. Photon means light energy. Light energy. The packet of energy. You think about this first. Actually, it's more complicated, but you just remember photon is light energy. Blue photon has frequency higher than threshold frequency. Threshold frequency. So, the photon is high to overcome the work function and emit electron in maximum kinetic energy. Okay, so we say E of blue equals to work function plus kinetic energy. So E of blue may be 15 joules equals to 4 joules of work function plus 11 joules of kinetic energy. That's why when there are when there's energy more than work function is energy, work function is energy, then only we can have kinetic energy to emit out the electron. Emit out electron means electron move in high speed. Move out. Emit means electron move out with high speed. Okay, so we say work function equals to H naught. Okay, then what is the application of photoelectric effect in our daily life? We use it as our solar cell. Okay, so solar cell means got light. We emit our electron to the load. No? Okay, so so far here, last page 212. What is a beam of white light containing frequency between this to this? Its incident means shine. It's shone on a sodium surface, is a metal surface, which has a work function of 2.28 eV. EV is another type, another unit for energy. We study this next week. Normally we use joules, right? But also we can study in EV. And I will skip this first. So yeah, so for example, number 6, page 214. Page 214. Okay, in Einstein photoelectric equation, half mv equals to hf minus w for a metal. What is the symbol of W represent? Or we can arrange it back into the form first. E equals to H, the photon equals to work function plus KE max. Photon means packet of energy. Photon means energy. Okay, so photon actually is HF equals to W naught. Since it's W means we put it as W naught plus KE max half mv squared. So we rearrange it, we will get HF minus W naught. So this W actually means work function. So what is a work function? A, B, C, D. Like answer, then let's try. And type answer for me. Thank you, Yu Guang. Thank you, 2 votes. 2% vote for C. Correct. Minimum energy of the photon means the light energy. Photon means light energy that can eject one photoelectron from the metal surface. Yes, answer is C. Work function. Okay, it's minimum energy. Correct. Maximum wrong lah. So looks like the same, but actually is about photoelectron, right? So you can try before we finish, look at this page first. Okay, this is an solar cell of electric power. You are required to find the most efficient solar cell system to convert light energy into electrical energy. So which one is the best? Semiconductor, not metal. Why? Because you haven't learned in chapter 5. Semiconductor is the best. Number of solar cells should be more or less, of course lah, more lah. Then intensity of light should be high lah. Then the solar cell should be series or parallel. Answer is series. P. Yeah, correct. Why series? Okay, thank you, Isong, because like this. If series, we can add up. For example, 1, 2, 3, 4, 5. 5 times 1.5, we will get 8.0. But if we make it as parallel, means wherever they stumble, it's just 1.5. So correct lah, decrease resistance, correct. But actually we want higher voltage lah. Okay, so far we finish until here. Then next week, no, then next week how I might get 2 classes, 1 class for Form 5, 1 class for Form 4. We will see how to solve the questions of EV instead of joules. Okay. That's all for today lah. I recorded and I will upload it. Can you all help me to send the link into your class? Okay, so I think before exam, somebody might need this lah. Okay, so that's all for today. Thank you, class. Bye-bye. Say bye before you go. Bye-bye. 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 Welcome.
哦，teacher，
Yes.
那
来来，
个 superconductor 被证实是假的了，
怎么呢？
因为它的特性其实是跟 high temperature superconductor 是一样的，就是差不多是200、100多 K 这样子。
哦，是咯。
就它不算室温 conductor 嘛，所以代表它这个就目前来讲，没有人认为它是真的。
哦，是咯，我看到也有些 YouTuber 在讲了。好啦，谢谢
哇，
你的分享。
这样精彩的科学之战。
是咯。